Okay, today we're going to look at isosceles and equilateral triangles. We're going to talk about legs, vertex angle, base angles, the isosceles triangle theorem, the converse of the isosceles triangle theorem, and then some equilateral triangle corollaries. We should all know what an isosceles triangle is. It is a triangle who has two congruent sides. So if I have triangle A, B, C, then I could say that side AB and side AC are congruent. This is an equilateral triangle. The two sides that are marked congruent are called legs. I guess that would just be one leg over here. All right, so those are each legs of the isosceles triangle. The two legs make up what is called the vertex angle. So the vertex angle is at the top of this picture. And then you have base angles. The angles at the bottom of the triangle in this picture are called base angles. Okay, so I have two congruent legs. I have those two congruent legs make up the vertex angles, and then the angles made by the base and a leg are called base angles. So if you want some definitions over here, legs are the two sides that are congruent in an isosceles triangle. The vertex angle is the angle formed by the two legs. Base angles are the two angles formed by a leg and base, and there's two of those. And if your triangle is written this way, then they'll be at the bottom, but sometimes your triangles are written sideways or upside down, so I don't really want to say they are the bottom angles. But if you notice, across from those base angles are the congruent legs. So anytime you have angles that are congruent, across from them are also going to be congruent to each other. All right, so a really important theorem is called the isosceles triangle theorem. There's two of them. You have the regular isosceles triangle theorem, and then you have its converse. And if you need to, you can pause this if I'm starting to move too fast here, if you're still copying some things down. All right, the isosceles triangle theorem says if you have a triangle, and we'll call this triangle DEF, and I know that my legs are congruent. So if you have an isosceles triangle and the legs are congruent, then we can conclude that angle E is congruent to angle F. The base angles would be congruent to each other. So if you have an isosceles triangle, then we can conclude the base angles are equal to each other. The converse is the opposite of that, meaning if I have a triangle, we'll call HAT, and I know that angle A is congruent to angle T, then I can conclude the sides opposite those angles are congruent. So side HA would be congruent to side HT. So that is the converse. So if you know the angles are congruent, then we can conclude the sides are congruent. That is the converse. It's basically the reverse of the isosceles triangle theorem itself. All right, so we might need that in some of our proof writing that we've been working on. So those are some good concepts that we can apply. The equilateral triangle corollaries, just basically remember a corollary is something that follows a proof. So somebody out there was like, triangle, the isosceles triangle theorem, and then they're like, ooh, what about equilateral triangles? So they came up with these two corollaries, and there are two of them. The first one says, if you have an equilateral triangle, I will call, let's see here, MOP. Really creative there. And I know that the sides are all equal because it's an equilateral triangle, and we know that all the sides are equal in an equilateral triangle. Then I can conclude that angle M is congruent to angle O, which is congruent, let me write the right symbol here, congruent to angle P. So if the sides are all congruent, then we can say the angles are all congruent to each other. And we talked about that already. That equilateral triangle is also known as equal angular triangle. And the reverse of that would be if your angles are all equal, then your sides are all equal. So if I have triangle L A X, I don't know, I'm just making up letters. All right, and I know that L, A, and X are all equal to each other. Then what can we conclude? That side LA is equal to side AX is equal to side LX. So those are the two equilateral triangle corollaries. Makes perfect sense. Equilateral is also equal angular, and that's all that says. So that is the main idea for an isosceles triangle. The only new big thing here is the isosceles triangle theorem. If you have an isosceles triangle, then the base angles are congruent to each other. So that's the main idea behind that. If you flip your paper over, then you will see some practice problems here. And if you want to, you can pause the video, see if you can find some congruent angles based on AB being congruent to CB, see if you can do number 2, so forth and so on. So you can pause the video and then unpause it to see if you got all these answers correct. So what I'll do is I'll just work these out and put the correct answers. All right, so I like to highlight and find which triangle they're looking at. So that's the beauty of this little tablet here that I'm working on. You can always highlight and then erase if you've got some colored pencils or whatever. All right, so I'm going to find side AB, and I'm going to find side CB. So we're clearly looking at this big triangle. I'm just going to color in. So I need to figure out if AB is congruent to side BC, then what would be congruent? That would be these base angles. Unfortunately, I can't say angle A is congruent to angle C because I don't know which angles you're talking about. There's more than one angle at that vertex, so that would be incorrect. Make sure you use 3 letters to name the angle, such as angle BAC would be congruent to angle BCA. So again, make sure that you use 3 letters to name an angle, especially if there's more than one angle at that vertex. I would just say when in doubt, use 3 letters so you don't get it wrong. All right, number 2. So I'm going to erase all my highlighting here because I'm pretty sure we're going to talk about a different triangle. So if I find angle EAC, this tiny angle down here, is congruent to ECA, this little that little angle down there. So we're clearly talking about this small triangle in here. So which sides would be congruent? If that were true, I could say side AE, because it's across from that base angle, is congruent to side EC. So anything that is across from it are going to be congruent to each other. Number 3, FH is equal to what? Well, if those 2 angles are both 60, that would leave H to be also 60. That makes this an equal angular triangle. We know equal angular is also equilateral, so each side is 12. Number 3, it's an equilateral triangle, so all my angles are equal to each other. 180 divided by 3 gives me 60 degrees for each angle. Number 5, if this is an isosceles triangle, because only S and T are marked congruent, so SR is congruent to RT. I don't need the 7. The 7 is not going to help me. So instead I've got 2Z minus 15 equals 9. I'm going to add the 15 to the 9, and you get 24. Divide by 2, and Z equals 12. Number 6. I know that 8 is equal to 8, so that's an isosceles triangle, making the base angles equal to each other. So 62 is equal to 4x minus 2. So I can add the 2 to the 62 and get 64 equals 4x. Divide both sides by 4, and x would equal 16. So how did you do? Did you get that part correct? Just using some algebra. If your sides are equal, then the base angles are equal. So that's all we're practicing there. The computer went to sleep. All right, number 7. We have a little proof here just to practice what we have talked about and to add the new theorem in here, the isosceles triangle theorem. So remember, our goal here is to prove triangle ABE. Always look to see what you're trying to prove. So I'm trying to prove triangle ABE is congruent to triangle CBE. So focus in on that. You're given that ABC is an isosceles triangle, and you know that EB bisects angle ABC. So I know I can add some stuff. So if BE is bisecting angle ABC, that would make this angle congruent to this angle. And I know I've got reflexive property, so BE is congruent to BE. So my triangles are congruent because of side angle side. So that's the plan. It's always good to plan ahead before you start writing up your proof. The first thing is you're given. So triangle ABC is isosceles. EB bisects angle ABC. And I always just cram everything I'm given into that first step. All right, so then you want to take what you're given and kind of write something based on that information. So because I know ABC is an isosceles triangle, I know that side BA is congruent to side BC. And this is definition of isosceles triangle. And EB bisected angle ABC, so that's where I marked those two angles at the top. So angle ABE is congruent to angle CBE because of definition of angle bisector. And then I could say that EB, that was another thing we had marked, EB is congruent to EB because of reflexive property. We've done that one a lot. And now I have enough stuff to say my triangles are congruent because that's what I'm trying to prove. So ABC, or ABE, excuse me, it's congruent to triangle CBE because of side angle side. And that's why it's very good to plan ahead so you know what your end goal is. My end goal is to prove those two triangles to be congruent. All right, so hopefully you paused the video and you tried this back side of this worksheet and you checked your answers and you did very well. And so now your assignment is that worksheet that's stapled to the notes page. You will complete those 9 problems, take a picture of it, and upload it into Google Classroom for me. So that way I know that you watched the video and that you understand what you hopefully learned. If you have any questions, remember you can message me or email me, and I will talk to you guys later. Bye.